Okay, welcome everybody to our Mathz Pidgin channels. So we still did our matter with log readings. We still did common log reading matter. For our last class, we will discuss common log reading of numbers greater than 1. Numbers greater than 1. So I've been telling you, say for this our class, we will discuss numbers way small pass 1. Alright, now we see this number 0.1. 0.1 small pass 1. But what will be the meaning of this one? This number is decimal, abi? Some people they call a decimal fraction. Some people they call a decimal number. Some people they call a fraction. Fraction means say this number now the result of some number divided by another number. Example, if 1 divide 10, it will give us 0.1. So this part now is a fraction, this part now is decimal. So you see say this number they less than 1 because we divide 1 into 10 pieces. Therefore, the result what we get now 0.1. Abi? So check this one out. If we divide 1 into 100, it means say we don't divide 1 into 10 raised to power 2. Because 100 and 10 raised to power 2, abi? Why this one and 10 raised to power 1, abi? So if we divide 1 by 10 raised to power 2, our result will be 0.01. And what our result will be? Abi? This number 2 still small pass 1. But try another one. See this number now. If I divide 1 into 1,000, it means say I don't divide 1 into 10 raised to power 3. Abi? 10 raised to power 3 could give me 0.001. If we divide this number into 100 like this now, we'll get 0.83. Now what we will get? Abi? Now what does this number mean? This number means say we don't divide 83 by 10 raised to power 2. Abi? Now, as it be like this, all these results they small pass 1. Now, because they small pass 1, we still express them in standard form. So if we express them standard form, then we don't express numbers less than 1 in standard form. For here now, I don't divide this one into 10 and 10 raised to power 1. What does it mean? It means say if I get number over this, I will express them as 1 times 10 raised to power minus 1. Abi? Now what does this one mean? If you follow us for our indices, for indices, it say any number raised to any negative power, we will take the reciprocal of that number. Now, if 1 divide 10 raised to power 2, we get 1 times 10 raised to power minus 2. If 1 divide 10 raised to power 3 like this, we get 1 times 10 raised to power minus. And then for this our last one, our number could be waiting. So if we divide this by this, we will get 83 times 10 raised to power minus 2. Now waiting our answer B. Now, all these numbers, they are in standard form, except this one. This one no dey standard form. I will tell you why this one no dey standard form. So why this one no dey standard form? Now because we say we express number in standard form, we go do this one 8 times 10 raised to power n, abi, where our a dey between 1 and 10, abi, and our n go be integer. So for this number now, this our a here, it dey more than 10. We get 83 times 10 raised to the power minus 2. So 83 dey more than 10. So if you want to do this one or change this one, we'll get 8.3 times 10 raised to the power minus 1. So we don't express this number in standard form. If you want to express any number less than 1 in standard form, then the power of 10 will be negative. Now what you supposed to note is that this number dey less than 1. So the power of 10, when we express it in standard form, dey negative. This number also dey less than 1. So the power for standard form dey negative. Number 2 dey less than 1, and the power in standard form are negative. So now this number wey I express like this, you know dey standard form. This one na standardized for the standard form of this number. Now in dey here. So make we express numbers less than 1 in standard form. So we will say, so express the following numbers in standard form. All these numbers now they dey less than 1. Abi? So to express them in standard form, now you go just pick the first number. Just pick the first non-zero number for the numbers less than 1. The first non-zero number for here now waiting now 4. Then you go just answer by 10. Because now less than 1, we already know say the end could be negative, abi? So we go put negative for the power. Then the next one what we go do now to count the number of zeros. We just count 1, 2, 3, 4, 5, 6. 6 zeros. We go put them like this. So we don't express them in standard form. So we don't get them, abi? So this one too. We first count the first non-zero number. The first non-zero number is 7. So we say 7.1, abi? Then we will do times 10 raised to power minus, then we will count the number of 0. How many 0? 1 0, abi? So this 0 and 1, we just put 1 for here. We don't express in standard form. So this one, the same thing. The first non-zero number now waiting, now 1, abi? So we will say 1.5. 1.5 like this. Then times 10 raised to power minus. Then we'll count how many number of zeros what we get. How many number of zeros we get? 1, 2, 3, 4. So we'll just put 4. Abi? And then here we'll just do 18. The first non-zero number now 3 times 18, 10 minus how many zeros we get? 1. So we'll have raised to power minus 1. And then this one, we'll just count the first non-zero number at 7.2 times 10 minus. We'll count how many number of zeros so we get. 1, 2, 3, 4, 5. So raised to power minus 5. I hope say it clear. This one simple, abi?